I started LittleHorse with the goal of helping make engineers more valuable to their enterprises by giving them a higher level of abstraction to operate at that's closer to the business process and therefore closer to the business value. And that's the core philosophy behind business as code. You want to be able to write code at the business process level and have that code be executed and orchestrated across many different systems, whether you're dealing with SaaS integrations, microservice workflows, or agent workflows. In any case, you're going to have the problem of having to orchestrate processes across many disparate systems. Before LittleHorse, the problem I kept running into was that our business process logic was scattered across many different systems, hidden in Kafka consumers, hidden in point-to-point RPCs between systems. It was just very difficult to observe business processes end-to-end, let alone get any insights into how they were actually performing. All of this was confounded by server sprawl, where we didn't actually know what APIs were available, what was their schema, and we had no guarantees that as new versions were deployed, downstream consumers wouldn't break. That's why we created the LittleHorse Server. We wanted to give engineers the ability to write code in one place that describes an end-to-end business process and have it be orchestrated across many different services, whether they're agents, microservices, external SaaS systems, or legacy apps. Let's take a look at how the LittleHorse Server works. This is the architecture page on our GitHub README. So first, to use LittleHorse, you have to define your workflow specification and register it with the LittleHorse server. The workflow specification describes your business process end-to-end in code. When you run a workflow, LittleHorse will consult the business process via the workflow specification and decide what tasks to dispatch to what task workers in what order. Task workers are processes, pieces of code that you write that connect to LittleHorse and pull on a task queue and execute tasks when LittleHorse tells them to. It's very easy to take code that you already have and turn it into a task worker. Likewise, it's very easy to connect to external systems, such as Salesforce, SAP, NetSuite, or any other legacy system that you have, and turn that into a task that can be composed into a workflow. Let's jump over to the LittleHorse dashboard. This is the task get page. For example, verify identity is the task that we're going to use in the quick start workflow that we'll go over shortly. Verify identity takes in a full name, an email, and a social security number, and it returns a string. We can see there's one worker that's pulling on this task queue, and we can see that it's been executed a couple times in the past. So where does this task come from? This is the code where the task worker comes from. As you can see, it's just a normal Java method with a special annotation on top of it. We can use this task inside a workflow. So this is the code right here for the quick start workflow, which is a know your customer process or KYC process. First, we execute the verify identity task, requesting that a third-party SaaS service start an identity check for an incoming customer. And then we wait for an event, which signifies the response from that asynchronous third-party process. We handle a timeout error, and then we either accept or reject the customer, depending on the result that we got from the third-party SaaS. So let's take a look in the dashboard. We go to the LittleHorse dashboard, we can see the quick start workflow right here. And the process that I just described in code is visualized perfectly in the LittleHorse dashboard. And this visualization is deterministically generated from the code that we saw in the previous step. So one nice thing about LittleHorse is if your agent writes code and you don't really feel like reviewing what it did, you can just take a look at the dashboard and see what the agent did. I do that all the time. Don't tell my boss. Now let's run the workflow. Well, remember earlier I said that LittleHorse puts events into Apache Kafka in real time as workflows complete. This is a core differentiator of LittleHorse compared to other workflow engines because it gives you real-time visibility into your process at the business level, whereas simple durable execution engines only cache side effects and allow you to restart them. So in a second, we're going to run the LittleHorse workflow and we'll see the events in Kafka as the workflow progresses. Well, we can see that the workflow has been created, and we can also see that the task verify identity task was scheduled, then moved into the running phase, and then was completed and returned this output that the third-party API was successfully called to request verification for Mace Windu at mace@jedi.temple. Now let's take a look at the workflow run. We go down to the dashboard, we'll see the running workflow right here. And the workflow is blocked on this node waiting for the response to come back from the third-party system. So let's use the LittleHorse command line to simulate the event coming in from the third-party system. Okay, we can now see that the workflow has been completed. Let's check it out on the dashboard. Well, it appears that Jedi Master Mace Windu's identity was successfully verified and he's been added as a customer. Well, that concludes the overview of business as code with the LittleHorse server for today. See you next week.